Now that we have understood how ingredients and processing have contributed to the microstructure of yogurt, it is equally important to understand how changes or variations in quality can impact acceptability of the final product in terms of rheology and sensory attributes. Knowledge of the behavior of yogurt during long-term storage. In order to obtain uniform rheological and sensory properties when producing yogurt in large quantities, it is important to ensure that milk and cream are standardized. As discussed in previous videos, total solid content of yogurt plays an important role in determining the consistency and hence the viscosity of the yogurt gel. Due to the high fat content in cream, it is easily prone to lipolysis and rancidity affecting sensory characteristics of the product. Pasteurization is a crucial step in both safety as well as rheology of yogurt, as improper pasteurization may lead to fermentation due to enzyme activation resulting in stringy products due to casein precipitation. Care should be taken in order to ensure product is stored at below 4 degrees Celsius to limit microbial growth, and packaging must limit oxidation. Experiment 1. Viscosity or flow behavior. In order to study flow behavior and viscosity of yogurt samples, a setup similar to Stein cup is used. Yogurt samples with 6.2% fat is used as control, and Valia fat-reduced yogurt with 1.9% fat is the test sample. Yogurt is transferred to the Stein cup and filled to the starting point. The opening of the cup is released and time taken to reach end point of 15 ml is recorded using a stopwatch. Similar method is followed for the test sample. It is recorded that the control sample drained in 11 minutes 15 seconds, whereas the test sample drained to 15 ml in 7 minutes and 52 seconds.
That shows us the low-fat yogurt has a higher consistency than the full-fat Greek yogurt, which means an increase of yogurt viscosity as fat content of milk base increases. That may be due to the higher level of crystallinity in milk fat because of its higher content of saturated fats. Furthermore, examinations by transmission electron microscopy also revealed interactions between protein and milk fat related to the increased viscosity and water holding capacity.
Experiment 2. Syneresis test. Syneresis is basically the oozing of a liquid from a gel structure while the gel is standing or as it is being cut. It's an important quantity test in yogurt industry. When the gel structure of yogurt is relatively weak, water can escape quite easily.
In this experiment, we aim to study syneresis in control and test samples by measuring the runoff or the base serum. 2 tablespoons of yogurt control with 6.2% fat is placed on a sieve and let to drain for 10 minutes. After 10 minutes, the runoff is measured. Similar experiment is performed on test sample with 1.9% fat. It is observed that 2.5 ml serum has drained from control and 5 ml has drained from the test sample.
So, what leads to the difference? As the yogurt gel structure shrinking itself, the free water is pushed out and travels to the surface within the confines of the container. As the total solids contained in the yogurt is increased, the casein particles chain becomes shorter, the pore dimensions are diminished, and the density of the matrix is increased, so the water is hard to escape from the network. Therefore, in this experiment, the difference is because of the quantity of milk solids, and the nutrition of whey proteins of test group is lower than the control group.
Control yogurt samples with 6.2% fat and test yogurt sample with 1.9% fat was tested and ranked on a hedonic scale by 3 panelists. The samples were marked for appearance, mouthfeel, flavor, profile, and acidity on a scale of 10, with 0 being least and 10 being most of each of the characteristics. From the graph, it can be seen that control sample is ranked higher in appearance, mouthfeel, flavor, and acidity. It is evident from sensory testing The control with 6.2% fat had performed better than our low-fat Valia yogurt. This can be attributed to the flavor delivery properties of fat. Fat is an important flavor solvent, and flavor compounds partition themselves between fat, water, and air phases in yogurt. Evidence suggests that changing fat content of yogurt results in modifying volatile composition, volatile intensity, and rate of release. Also, defects in sensory properties of yogurt arise due to inefficient use of ingredients and poor processing and handling methods. Thanks for watching. We hope you enjoyed all our videos as much as we loved making them.